Hello dear students. So now I am going to start with a new chapter which is prescribed under paper 6 in your 5th semester. So there unit 2 chapter 2.2, that is flame photometry. So blow up of the syllabus is we are going to discuss about the general principle which is involved in flame photometry, and we have to concentrate on instrumentation. So what and all the parts are involved in the instrumentation of a flame photometry, and what are the different types of flames used to perform this flame photometric experiments. So as the name itself says, we need to use the flames. So different types of flames are there, what and all the different types of flames are there, and what are the interferences? Interferences means in simple word disturbances or interferences which are caused to the flame photometry, that will be discussed, and analytical applications of flame photometry in the estimations of sodium, potassium and calcium metal ions will be discussed in this chapter 2.2. Okay. So now let us move on to the introduction part of flame photometry. So what is meant by a flame photometry? So just like how we discussed the conductometric titrations in our previous classes, so there we were using conductometer to measure the conductance. Okay. So in the same way, so flame photometry is a technique in which we are going to use a flame photometer, which is a device used in inorganic chemical analysis. Okay. So this is used in inorganic chemical analysis to determine the concentration of certain metal ions, among them mainly sodium, potassium, lithium and calcium will be determined. These metal ions, the concentration of these metal ions will be easily determined with the help of flame photometry. Okay. So mainly group 1 and group 2 metals are quite sensitive to flame photometry, so due to their low excitation energy. So flame photometry is an instrument which is used to determine the concentration of metal ions. Okay. So that is the main part what we have to understand here. That too especially the group 1 and group 2 elements which are present in the periodic table, that is group 1 are alkali metals like lithium, sodium, potassium, rubidium, cesium, and group 2 is alkaline earth metals. So these are very sensitive towards flame. Okay. So that is because of their low excitation energy, so they seem to be very sensitive towards flame photometry. Okay. What happens here is, so in this flame, so when these elements comes in contact with this flame, what happens is the excitation of source is going to be observed, and an electronic photodetector is used as the measuring device. We are going to measure. So once these elements comes in contact with the flame, they are going to excite from their lower energy state or ground state to the higher energy state. However, so they are not stable in the higher energy state, they have to return to the ground level, ground state. So while returning to the ground state, so they are going to emit the light. Okay. So the energy what has been absorbed by the element to excite from the lower energy state to higher energy state is emitted when they return to the ground state. So how much amount of light has been emitted, the intensity of the light emitted is detected using a electronic photo detector. Okay. So that is a measuring device which measures in what intensity, in how much amount of intensity the light has been emitted when a metal is introduced into a flame. So that is determined. The wavelength of the color is used to identify the element, and intensity of the color describes the concentration of the element. Okay. So each element has got its own characteristic color. So that color depends upon at what wavelength it is going to emit the light what has been absorbed by it. So that determines the concentration, and also the intensity of the light determines how much amount is present how much amount of sodium or potassium or lithium is present in that given sample is measured. Okay. So, flame photometry is also named as flame emission spectroscopy, that is because here the flame to provide the energy excitation to atoms introduced into the flame. So, that is why we call it as flame emission spectroscopy. Okay. So, now let us move on to the principle involved in flame photometry. So, to summarize it or to see it in a simple way, so what happens in this flame photometry? Let us see it in step by step manner. So, first the metallic salt solution. So, these alkali metals are mostly used in flame photometry. So, what and all the solution we are going to introduce into the flame photometry, definitely it will contain a metallic salt. Okay. So, the metallic salt solution is introduced into the flame, and what happens is the following reactions are going to take place. First, the solvent vaporizes, leaving the particles of the solid state. Okay. So, when this solution which contains metallic salt is introduced into the flame photometry instrument, so what happens is as soon as the solution comes in contact with the flame, the solvent or water is going to get evaporated, leaving behind the particles of the solid salt. Okay. So, that solid salt itself will be left once the solvent is vaporized. And the second reaction what is going to take place is, next the salt as it continues its contact with the flame, so it is going to convert into a gaseous state. Okay. A salt which will be in a solid state is going to get converted into a gaseous state. Next reaction what happens is, some of these gaseous atoms may excite to the higher energy level. Okay. So, those who have low excitation energy or those who have valence electrons which are revolving at the outermost shell of the nucleus, they will be more sensitive and they absorb the energy in term of a flame, and they will get excited to the higher energy level. On returning to a lower or a ground state, the excited atoms emit radiations. Okay. So, this is a characteristic feature of any element. If we take any element, all element will behave in the same manner. When it absorbs energy, it will excite to the higher energy state, but however it can't stay there in the higher energy state for much longer time. It has to come back to its original state or its ground state, relaxation state. While returning to the ground state, what happens? So, it re-emits the energy which it has absorbed in terms of flame or heat. It is going to re-emit it. Okay. So, that re-emission of energy, the emitted radiation is passed through a monochromator and spectrum is registered. Okay. So, what is meant by a monochromator? A monochromator is a device which is used to select radiation of a single wavelength or energy. That means it filters, this monochromator is going to filter, it will allow only a single wavelength of light to pass through it. Okay. And next spectrum, which refer to the band of colors formed by a beam of light. Okay. So, by using this monochromator and spectrum, so we are going to register how much of emitted radiation is passed through. So, it is measured in a instrument what is called as a photodetector, and this is the main principle of flame photometry. Okay. So, to summarize the principle, I can say that when sodium and potassium are atomized into a flame, their valence electrons are excited to higher energy level. Okay. So, the valence electrons which are there in sodium and potassium, so they get excited to their higher energy level. As this electron return to their normal ground state energy level, so they emit photons of light energy. Okay. So, this is the basic principle which we see in case of flame photometry. So, this is the diagrammatic representation of the process which takes place in flame photometry. Okay. So, as I said, let me say this is a solution where I have metal along with its anion. Okay. Say for example, if I am performing the experiment of potassium hydroxide, so X minus will be the OH minus, that is water, and M plus means sodium, Na plus. You imagine like that, or this is the general representation, let it be like this only. M means metal and X means so which has been which has to separate or which has to excite to the higher energy state. Okay. So, in the solution, so this is the dissociated form of a metallic salt solution. Okay. So, this is a metallic salt solution. So, what happens, the solvent vaporizes, that means, so here evaporation is going to take place, the solvent vaporizes and then it will convert it into the solid compound, that is Mx. Let me represent it as a Mx. Okay. And next this solid is going to get vaporized. Okay. So, once after getting vaporized, what happens, this solid is going to get converted into a gaseous form. Okay. Once it converts to the gaseous form, here the dissociation is going to take place, that means M plus and X minus will be formed. So, this metallic salt is going to get dissociated, and when it gets dissociated, definitely it will have a valence electrons which will be revolving around the outermost shell of the nucleus. So, that will absorb the flame energy, that is thermal energy, and these ions will excite to the higher energy state, that is M plus and X minus. Okay. But it cannot stay there for a long time, it has to return back, it has to come back. So, thermal excitation is going to take place, and then so here when it returns to the ground state, so it is going to emit the energy what it has absorbed in terms of flame, and gas emission will occur with the transmission of light, which has been represented in terms of h nu. Okay. So, this is how the diagrammatic representation of flame photometry can be explained. Okay. And our next part of interest in this topic is instrumentation. So, the essential components of flame photometry are, so I can classify them into 4 types, that is, the first one is a pressure regulator, the second one is nebulizer, the third is optical system and detector, and the fourth one is amplifier and readout system. Okay. So, let us see one by one. So, what is meant by a pressure regulator and flow meter to the fuel and oxidant gases? Okay. So, these are essential to have a uniform spray and constant thermal environment. Okay. So, I have to maintain a constant thermal environment here. The thermal environment should not change, because if it changes, what happens is I will get irregular results. Okay. Say for example, if I am determining the concentration of sodium, so in the next class when doing the analytical applications, there we will see. So, while determining that, so I have to get a straight line, okay, and it should satisfy Beer-Lambert's law, straight line with the slope. I have to find out the unknown concentration, just like how we will perform the spectrophotometric experiment. In the same way, the graph has to be plotted. Okay. If I do not maintain the uniform thermal environment or constant thermal environment inside the chamber, inside this pressure regulator chamber, so definitely I will see a irregularity in the results what I am going to get. Okay. So, the fuel can be directed from a cylinder, while the oxidant is very important here, because for a flame to burn, so oxygen is required. Without oxygen or without air, so flame will not burn, so then we cannot do flame photometry experiment. Okay. So, for that purpose, so the oxidant is sent from the compressor. Okay. So, this is what is the unit where we can see the pressure regulators along with the flow meter to the fuel and oxidant gases. Okay. And the next component in this instrumentation is a nebulizer or a burner assembly. Okay. So, this is a system. So, this is a burner. So, here only a nebulizer also will be there. So, what is meant by nebulizer? So, nebulizer is a device which is present inside the flame photometry. The function of this nebulizer is to produce a mist or aerosol of the test solution. Okay. So, mist or aerosol means so it will not it will be in the middle state, that is it will not be in a liquid state or it will not be completely in a gaseous state, in between liquid and gaseous state. So, that is what is called as mist or aerosol. Okay. What the nebulizer will do is, the function of the nebulizer is to produce a mist or aerosol of the test solution. So, this is achieved by drawing up the test solution through a capillary tube. Okay. So, in the flame photometry a capillary tube will be there. So, that capillary tube, it is going to aspirate the solution. Okay. So, it will aspirate the solution and it will move that solution to come in contact with the flame. Once it comes in contact with the flame, the nebulizer is going to produce a mist or aerosol. Okay. And that capillary tube, using a jet of air at high pressure, will aspirate or will suck the sample solution. The mixture of fuel, gas, oxidant and aerosol of the test solution move towards the burner head. And okay. So, this is how the nebulizer or the burner assembly is going to work. And next is optical system and detector. Okay. So, this is the optical system. So, here it is connected to the burner and this square what you are seeing, so that is the lens, and here the slit also will be present. Okay. So, your slit also will be present. So, what and all the function is going to take place in optical system and detector means. So, these are used to select a given emission line and to isolate it from the rest. Okay. So, the radiation coming from the optical system is allowed to fall on the detector, which measures the intensity of the radiation on it. Okay. So, in modern flame photometers, the photo multiplier detectors are employed, which produces a electrical signal from the radiation falling on them. So, here the how in what intensity the light has been emitted by that particular sample is measured with the help of a optical system, where we are going to use the lens and slit. Okay. So, this is what it is going to happen in optical system and detector. And the fourth component is a amplifier and a readout system. So, the filtered radiation. So, slit, why do we use the slit means, so slit is used here to filter the radiation. So, the filtered radiation passes into a photocell and the output of which is measured using an amplifier and readout digital system. Okay. So, this is the readout digital system. Here I am going to get the readings and I will note down the readings of that particular sample. Okay. So, this is how the instrumentation of flame photometry will be explained. And so, this is what I already explained by using this picture. So, the same thing has been explained here. So, the components of flame photometry are pressure regulators, nebulizer, burner assembly, and the third one is optical system, and the fourth one is amplifier and readout system. Okay. And next let us move on to the different types of flames which are used in flame photometry. So, if we use a hydrogen fuel and oxidant as oxygen, so we will get flame temperature up to 2800 degrees centigrade. Okay. So, different types of flames have varying temperatures depending upon the oxidant and fuel used. Okay. So, the different temperatures obtained by using different fuels and oxidants are explained here. Suppose if I use H2 as fuel and general ordinary air, so I will get 2100 degrees centigrade of flame temperature, and if I use H2 as fuel and argon as oxidant, I can attain 1600 degrees centigrade. If I use fuel acetylene and oxidant as oxygen, so I can go up to 3000 degrees centigrade flame temperature, and if I use acetylene as fuel and air, then 2200 will be the flame temperature, maximum flame temperature which I can attain. And if I use acetylene as fuel and N2O, then I can go up to 3000 degree centigrade. If I use propane and O2 as oxidant, I can move up to 2800, and if I use propane with using oxidant as air, so then it will go up to 1900 degree centigrade. Okay, so these are the flame temperatures. So along with this, further we have each and every element or a metal which is there in the group 1, that is alkali metals. They have got their characteristic wavelength and also the flame color. By looking at the flame color only, we can identify which element is present. Say for example, so sodium, if sodium is present in the given sample, so the emitted wavelength of sodium will be 589 nanometer and the flame color will be yellow color. Okay, suppose if sodium is present in the given solution, then the flame looks in yellow color, and if potassium is present, then the respective wavelength of potassium is 766 nanometer and the flame color will be violet. Okay, so violet color will be absorbed. Suppose if we have barium, okay, so barium in the given solution, so then the emitted wavelength will be 554 nanometer and the flame color will be lime green. Okay, so lime green color flame will be observed, suppose if barium is present in the given sample solution. In the same way, if calcium is present, so the calcium, it is going to emit the absorbed radiation at 622 nanometer and the flame color will be orange. Okay, so the flame will be in orange color. And suppose if lithium is present in the given sample, so the emitted wavelength of lithium is 670 nanometer and the color of the flame will look in red color. Okay, so this is how all the alkali metals which are present, so they will have their own characteristic wavelength and also they express their presence by their own characteristic colors. Okay, so if yellow color is appeared in the flame, sodium is present, violet is observed in the flame, potassium is present, like this each and every element has got its own characteristic color. Okay, so this is quite interesting while studying the flame photometry. So if we observe the color, that color gives us a lot of information in identifying the elements. Okay, so this is what about types of flame which we are going to use in flame photometric experiment. Okay, so in my next class, so we will discuss about what are the interferences in flame photometry. Okay, so as I said, interferences means the disturbances, what will disturb the flame photometric experiment. The results of flame photometric experiments are disturbed or interfered by two factors, that is one is spectral interferences and another one is chemical interferences. So what is meant by spectral interferences and what is meant by chemical interferences, that in detail we will discuss in our next class, and along with that we will see about the analytical applications where we are going to discuss about the estimation of sodium and potassium. Okay, so then you will be much more clear regarding the flame photometric experiment. And another one thing what I wanted to say you is, so this experiment was not there in your syllabus, but the university had told to do the demonstration of these experiments, but we have sent the proposal to the Star College scheme, where we have already mentioned that we are going to do this experiment hands on. So for that purpose we have already purchased two flame photometry instruments. So two flame photometry instruments are there, that to photoelectric flame photometry, which is digital one. So these experiments will be carried out by you practically, so you can do the experiment. So you will get much more clarity regarding this flame photometric principle and how to handle and what is the procedure used to identify or determine the metal ions by using flame photometry. Okay, so in my next class we will discuss about rest of the part, and that completes this chapter. Okay, so this is very small chapter where we have limited part, so we will discuss and we will complete it in our next class. Okay, thank you dear students.